This video covers where magnetic fields originate. So we already know that moving charges can experience a magnetic force, but moving charges also create magnetic fields, and this is what that video is covering. So let's look at these two current-carrying wires. The one on the right is a wire that has a current going into the wire. We have a second right-hand rule that we will use to find the magnetic fields around these two different wires. For this second right-hand rule, you place your thumb in the direction of the current and you curl your fingers in the direction of the magnetic field. So let's do this first example on the left. The current is pointing to the right, so you place your thumb pointing to the right. If you then curl your fingers, you notice that they curl up and then back into your hand. So this means that the magnetic field comes out of the page above the wire and back into the page below the wire. Now let's do the second example on the right. The current is pointing into the page, so your thumb points into the page. Your fingers then curl clockwise around the wire, so that is the direction of the magnetic field. We have an equation to describe the strength of a magnetic field a certain distance away from the current-carrying wire. The magnetic field is equal to the constant K prime multiplied by the current of the wire and divided by the distance away from the wire. Our constant, K prime, is equal to 2 times 10 to the negative 7th, and it has the units Tesla, meter, over amps. You have to do nothing with these units, though, when you place them into the equation. So let's do an example. An electron moves toward a 1 meter long wire carrying a current of 0.5 amps. If it is 2 millimeters away, what is the strength and the direction of the magnetic field? If the electron is moving at a velocity of 4 times 10 to the 5th meters per second, what is the magnitude and direction of the force exerted on the electron? So let's first look at the magnetic field. We must apply our second right-hand rule that we just learned to find the direction of the magnetic field. So our thumb points in the direction of the current and our fingers curl around the wire. We find that the magnetic field comes out of the page to the left and into the page on the right of the wire. Now let's find the strength of the magnetic field using our new equation. Our constant is 2 times 10 to the negative 7th. The current is 0.5 amps, and the distance away is 2 millimeters, which is equal to 2 times 10 to the negative 3rd power. This together equals 5 times 10 to the negative 5th Teslas. So that's our magnetic field right where the electron is. Next, we want to find the magnitude and the direction of the force on the electron. So we first need to apply our first right-hand rule to find the direction of the force. So the magnetic field is coming out of the page where the electron is. So our fingers come out of the page. Our thumb aligns with the velocity, and then we see that our palm faces downwards. But since it is a negative charge, we reverse the signs, and the magnitude of force points upwards. We can then find the magnitude of the force using our force equals ILB equation, where the current is 0.5, the length of the wire is 1, and we found that the magnetic field was 5 times 10 to the negative 5th Teslas. So we know that this electron feels a force of 2.5 times 10 to the negative 5th newtons.